Over to you, Bob.
All right. Thank you, Penny. Thanks for having us here. Adam and I are both excited to talk to all of you about dark skies, what dark skies are, their impact when there's light pollution on humans and wildlife. I'm going to specifically address that wildlife and plant issue because as a naturalist, that's my biggest area of expertise. I work for the Forest Preserve District of Kane County, as Penny said. I've been there for 9 years now. It's a second career for me. As a molecular biologist by training and did several years in doing the business of science, but now I have the best job in the world, being able to get out there and observe night skies and wildlife and plants and teach others about it. So I'm lucky enough that I met Adam during the pandemic, and we've actually never been able to meet in person. We're going to have to remedy that soon, but we've been collaborating on these talks. Adam, I'm going to introduce Adam, and then we're going to do a joint presentation. Adam's going to begin with his slide deck. I'll jump in and talk about wildlife and plant impact of artificial light in the night skies, and then Adam will finish up with some ideas of how we can all help correct the situation with some of the good news and the things that we can do in our own homes and our own communities. So Adam is a delegate of the International Dark Sky Association. He lives in Glen Ellen, so he's fairly local. He's passionate about preserving dark skies, and he's been very active in his community, both with dark sky organization and activities and other naturalist things like monitoring butterflies. I monitor butterflies, he monitors mushrooms. So
while we wait for Barb, thanks Penny, thanks Wally for inviting us to present tonight. I sincerely appreciate it. As Barb was discussing, I am a delegate with the International Dark Sky Association. I've been with the Dark Sky Association now for almost 2 years, and I'm here to speak on behalf of the association. So why don't we get right into my screen share. Okay, so here you can see the first slide, the International Dark Sky Association Saving Dark Skies, and you can see the Milky Way as part of this initial slide presentation. If you all have your pencils ready, if you could write down the Dark Sky Association webpage, which is www.darksky.org. I'd very much appreciate if you could visit that site. You'll learn a lot more from that site than you will from me today. A little bit of history. The light bulb was invented by Thomas Edison, if I remember right, I think in 1879, or at least that was the first time that the light bulb was actually presented for public display. Before that, we did not have any light bulbs at all. So for all the hundreds of thousands of years that we've been present on this planet, that our wildlife friends have been present on this planet, of course, many of our plants too. We've all had day and we've all had night, a dark night. And as a result of that, our bodies have developed into basically what we are now, which is creatures of day and night. And as part of that, of course, we've developed our circadian rhythm. And certain wildlife friends have developed a nocturnal lifestyle as compared to diurnal. So it wasn't too long ago when we had nothing but dark skies. And to the extent that we had any light at all, it was from gas lamps and, of course, candles. Vincent van Gogh painted Starry Night. I think it was in 1883 or something to that effect. And, of course, when he did that, he had nothing but dark skies. So here's a nice slide basically showing the progression of light pollution over years during which satellite imagery has been available. What I'd like you to kind of focus on is Lake Michigan and some of the other Great Lakes where we are. And you can see how there's so much more light over the lake,
even though there are no lights on the lake. So a huge part of light pollution, of course, is sky glow. So when that light is exposed out and up, it goes into the atmosphere and it just explodes across the atmosphere and spreads to, of course, all our neighbors. In 1950, you could see that we had very, very low pollution. And as we move into the 1970s and 1990s, and certainly now with the progression of LED lights, which have introduced a completely new number of health concerns to us, we have this huge expansion of light pollution, not just here in North America, but elsewhere. Now, most people live in urban areas, but regardless, statistically, only 2 out of 10 people on Earth can actually see the Milky Way. So you can see the Milky Way to your left. All the stars that we can see at night are part of our Milky Way galaxy. On the best of nights, here in this area, now maybe you can see a little bit more out in Kane County, where I'm at in DuPage County, we certainly can't. So even on the best of evenings, we can only see with our naked eye about 30 to 40 stars. Now, if not for light pollution here, we should be able to see with our naked eye as many as 2,000 stars. So as you move to darker locations out west, for example, and there are other locations, like for example, there's a dark sky park up at Door Peninsula. You will be able to see thousands of stars, but unfortunately here, because of light pollution, we can see very few, even on the best of nights. So here's a nice picture taken out west. You can see the Milky Way. Of course, you can see other stars. You can see a little bit of sky glow there from a distant village. And here you can see more stars. It's just nice to be able to show pictures where we get an opportunity to see what we would be able to see if not for light pollution. And of course, we can see Neowise here in this picture too. I don't know if anybody tried to find Neowise when Neowise was with us in the summer of last year, but I went outside on 4 nights, 4 pretty good nights, and wasn't able to see it because of the light pollution that I have in my neighborhood. So what basically is light pollution? Well, from the International Dark Sky perspective, light pollution more or less comes in 3 forms. It comes in sky glow, it comes in glare, and it comes in trespass. So here you can see to the left a good picture of what sky glow is. And you can see, as you can see, you know, even from flying in a plane, for example, you can see that we've got light going out. We can see that we've got light going up instead of light being directed to the ground where it should be. And again, this is especially significant with the recent use of LEDs and bright white LEDs. And here's just a little more of a demonstration of sky glow. We can see with the amber lights to the left, we have less sky glow and we can see more stars. And then here on the ground, one of the big problems that we're confronted with, again, especially with these bright white blue LEDs, is glare. A good example of that is with the automobile headlamps. So as we're driving, and this especially affects older people like me, for example, as we're driving, all we see is those bright white headlamps that are approaching us, and we almost have to look away because it's so bright and obtrusive. Well, as a result of that glare, our pupils, of course, constrict, and we're not able to see everything else around us. So, for example, we're not able to see a pedestrian that might be on a sidewalk, or maybe a dog that might be there by the side of the street, or whatever the case may be. So glare is especially a problem now with these white LEDs. And this is just a nice slide that basically demonstrates the response that our eye has to glare. So, and I'm sure you've seen this in the mirror, whatever the case may be, our pupils constrict. So basically our eye is allowing less light to enter for where our photoreceptors then receive it. And our depth of field is reduced and our reaction time is lengthened. If we're not confronted with glare at night, typically our pupils will, of course, expand, and we're going to allow more light to enter our eyes and reach our photoreceptors. And our eyes are, again, as part of that night-day cycle that we grew up with all the generations that preceded us, our eyes are able to allow 30 times more light into our photoreceptors so that we're able to see more of our environment. And you can do this any given night, and you'll see exactly what I'm talking about. And this is especially true with security. So for me, when I talk to municipalities or when I talk to counties or whatever the case may be, school districts, the biggest concern that I hear is security. Well, we need more lights to be more secure. Well, that's basically a myth. It's a non-truth. Actually, less light can be more safe. And most certainly, better lighting design will be more safe. So if you look at the example to the left, you've got that bright white LED light that's shining at you. That's all your eyes pick up, those bullet lights from that bright light. And of course, your eyes are constricting. But if you put your hand up against that light, and again, you can do this outside tonight or whatever, your pupils will expand, and you'll be able to see more of your environment around you. And then of course you can see the gentleman at the gate there. So if there was better lighting design with the light being shielded down, with it being less white blue and being less bright, we'd be able to see more of our environment. And of course that too affects our wildlife friends. The study suggests that actually more light causes more crime. There was a very interesting study in Chicago done with respect to when they lighted up their alleys. They found that more light in the alleys actually increased crime. And what we're finding is that criminals like light. They prefer well-lit areas as compared to darker areas. And then of course now with LEDs being installed in our residential homes, we've got this light trespass. So one of the things I encourage all of you to do is to basically try to measure what it is that you're doing at your own home. Go outside and try to see to what extent your lighting is affecting your neighbors. Are you lighting up the side of your neighbor's house? Is your lighting going in through your neighbor's window? Is your lighting up the robin's nest in the pine tree? Okay. Or is your lighting being directed down? Can you do with less? So light trespass is now becoming a very big issue. And of course, we can address it ourselves. Light pollution consequences, just briefly before I turn this over to Barb so that she can address the wildlife and of course the plants. One of the most significant light pollution consequences, apart from, of course, we can't see the stars, is energy waste. Every time we leave a light on that's not otherwise needed, we are consuming fossil fuels. And because of that, of course, we are also emitting greenhouse gases, which of course increases global warming. So anytime you don't turn that light off at night, you're actually causing the planet to become more warm. This is a busy little slide. For residential use only, this doesn't involve municipal use, this doesn't involve commercial or industrial use. For residential use only, and most of us here, of course, have lights at our own homes, 13% of residential electricity use is simply for outdoor lighting, even though we may not even be outdoors. even though we may not even know the lights are on. They're just always on, out of habit. And about 35% of that is wasted. And a lot of that is wasted from the context that, again, it's allowed to go out, it's allowed to go up, and it's allowed to become sky glow. The actual cost of all that wasted energy, wasted light, outdoor light, cumulatively, annually, across the United States is $3 billion, which adds up to about $10 per person. Incredibly, the amount of trees that we would need to plant to offset that waste annually would be about 600 million trees. That's how big too much outdoor lighting that's not otherwise needed is affecting our climate. So, human health. We're finding, especially now with these bright white blue LEDs, that light, that nature of light, that color spectrum is significantly affecting our ability to sleep well. And the reason for that is because it's causing melatonin to be, it's causing melatonin to be triggered less. We're actually affecting the amount of melatonin that's flowing through our body, our circadian rhythm. And I expect you've probably heard about this a little bit with respect to our handheld devices, for example. You know, there's a lot of research, a lot of publication now about how we should turn off our handheld devices, our computers and things of that nature an hour before we go to bed. Why? Because we want the melatonin to be triggered so that it's releasing at night. For whatever reason, during all those generations that preceded us, melatonin, a hormone, it's only released at night. And unless it's dark, it's not going to be released. And it's the melatonin that helps us sleep well. It's the melatonin that helps us have a good circadian rhythm. I'm not going to read this whole thing, but as recently as June 14, 2016, the American Medical Association, when addressing the increased use of bright white LEDs with street lamps for municipalities, cautioned municipalities about the use of bright white LEDs. And basically what the AMA stated was that they found that these bright white LEDs are affecting circadian rhythm, affecting our ability to sleep well, and ultimately affecting our health. So when you think about it, what are we doing when we're sleeping at night? We're rehabilitating, we're restoring. And if we're not sleeping well, we're not rehabilitating, we're not restoring from that difficult day we had. And also, with the melatonin, we're rehabilitating, we're restoring our autoimmune system, which of course helps us fight diseases, including theoretically COVID. There's some recent research from the Cleveland Clinic that suggests that problems sleeping are affecting our immune system, which affects our ability to fight diseases like COVID. And I don't know if some of you have heard, but there are a lot of people that are promoting melatonin as a home remedy to address COVID-19. And of course, here we've got the example of the blue blocker glasses. So now, of course, we're being sold blue blocker glasses to address that bright white blue LED light from our handheld devices and so on and so forth. But these glasses are also indirectly beneficial to address that bright white light, LED light, that's coming through our windows at night. And I'm sure, I'd like to think that probably all of you have had some level of experience with these new white, bright blue LED lights coming into our bedrooms at night. It's affecting our health. So, those are some of the detriments to, of course, our night skies, of course, to our climate, and of course, to our personal health. And now Barb is going to address some of the concerns that we have with respect to our wildlife and our plants. So Barb?
Thanks, Adam. And I apologize, I had a bit of a wonky internet connection. If my whole introduction didn't get through, I'm sorry. Let's hope it stays with us. So I'm gonna share my screen as well. Well, I don't know if I am the co-host. It says that I'm not able to screen share.
Barb, I don't think
You
I've
should
got
be
your-
set, Barb.
Okay,
Yeah.
thank you.
Sorry about that.
That's okay, no problem. All right,
There we go.
so we'll move from talking about humans to talking about some of these other animals and plants that are really sensitive to light pollution, and talk about why and what we can do to help change that. So we are diurnal creatures. Humans are not as active at night as some other creatures, but there's a whole world going on there after dark. And the animals that are active at night have many adaptations to do well in darkness. The main things that are happening in the evening with the wildlife in our natural areas and our backyards, really wherever you can visit in the outdoors, things that they really depend on the cover of darkness to succeed at and to live a full and a healthy life include nocturnal animals foraging and hunting. They're especially adapted in many ways to do this. From this owl skull that you see at the right, where you can see those very large eye sockets that the eyes in an owl have many rods, but not as many cones. So they have very good dim light vision, but not very good color vision. So they're especially adapted, as are all nocturnal hunters, to find prey in the evening. And those that are more prey animals like rabbits are adapted to do foraging in the evening. And they do this because in the cover of darkness, for prey animals, there are fewer predators out at night than there are during the day. And for predators, there's less competition in the evening. So there are good reasons that animals that thrive in the evening, hunting in the evening, do so. Other animals use the cover of darkness to find a mate, and they send visual cues that can be only seen in darkness. Courtship and mating is the prototypical animal that we think of there, the firefly. And that bioluminescent signal at the base of its abdomen is a nice cool light. And different species of fireflies have different color flashes and different flash patterns and rates to help attract mates and sometimes actually to lure in another species and cannibalize it. So without the cover of darkness, that signal would not be visible. Other animals that are active at night are specially suited to pollinating flowers that bloom in the evening. So this is an example of a hawk moth and a tobacco family plant, where that hawk moth proboscis is extremely long and the flower blooms in the evening and that hawk moth pollinates in the evening hours. There are other animals that do the same at night. And lastly, at night, we have birds that are active. There are nocturnal birds that are always active in the evening, but night is when many of our birds migrate. Scientists don't totally understand the science behind migration, but the theory is that birds, migrating birds, use celestial cues as well as the magnetic poles to find their way and navigate. And when there is light pollution, those celestial cues, like the moon and the stars, are difficult to see, making that migration very hard to accomplish. So these are all processes that our wildlife is conducting during the time that we're sleeping. And without nice dark evenings, the impact on all of these activities can be high. Scientists have long known that wildlife and humans need food, water, shelter to survive, but it's only recently that there have been many studies done that show that animals and plants also need periods of light and dark to thrive. Adam talked about melatonin and how humans need that to get a good sleep and to have their circadian rhythms functioning well and to be healthy. And it's the same with all animals and plants. And studies that were produced and published in the year 2003 started to use this term scotobiology. So it's a relatively new term. And scotobiology is basically the study of the biology of darkness and how that photo period does impact living creatures. So a fairly new term, coined at a Canadian conference in 2003, but it's taken hold and it's moved into more of the mainstream media at this point. After the Canadian study was presented at a conference and published in a journal, the book, Ecological Consequences of Artificial Lighting, was published in 2006. It does cite quite a bit of science. There's another easier to read book by Paul Bogard called The End of Night. That's another wonderful read about dark skies. You know that a topic has really hit the mainstream when it makes its way into children's literature. So this Dark Matters book was published in 2017 for children, explaining nature's reaction to light pollution and the importance of dark skies. And then lastly, for the musicians in the crowd, there is even a CD put out by a jazz trio in Brooklyn called Scotobiology. And we were talking about mushrooms at the beginning. I believe that's a lion's mane on the cover. I have no idea what that has to do with scotobiology, but you've got your music and you've got your literature all talking about the importance of light pollution and how darkness impacts all biology, really. So let's talk a little bit more specifically about specific impacts that light pollution has on the creatures that we have here locally. I work in a Kane County forest preserve system, so I'm always thinking hyper-locally. What do we have right here? What's in our own backyard? The book that I mentioned by Paul Bogard, The End of Night, categorizes 5 types of impact that we see on wildlife. The first is impact on orientation. This could include orientation in flight pattern when animals such as moths and other insects are attracted to porch lights. So they should be out foraging or they should be out trying to find a mate, but instead their orientation is thrown off, they're attracted to the light, and they're distracted from the activities that they should be doing. So a problem of orientation with light pollution. Other type of orientation that we often think about are birds who are thrown off course of migration when they're attracted to the lights of a tall building in a big city. Next is predation. I mentioned that animals that hunt at night do so because there is less competition. They depend on a dark evening to find their prey. So with light pollution, whether it's direct light or that sky glow that Adam talked about, it's the twilight, it's more twilight conditions. It's more difficult for, there's more competition from other predators, and for the prey animals, it's more difficult for them to hide and their predation rates are higher. Competition among the predators that are out there looking for those prey animals is also thrown off when there's light pollution. There are some species that do better in a little bit of light, and they outcompete those that don't when there is not a real dark night that they are suited to hunting within. Reproduction, talked about the firefly. There are a couple of other species that really depend on a dark evening to send out a mating signal that can be seen and found. And when reproduction rates decrease, so do species numbers. And lastly, circadian rhythms. Humans aren't the only ones with melatonin. They aren't the only ones with circadian cycles. And the influence of light on those circadian rhythms in other creatures is just as detrimental as it is to humans, as Adam was talking about. So all of these growth patterns and physiological processes that are set to sync with these circadian rhythms are impacted when the evening isn't dark, melatonin isn't produced, and the health of the animals decrease, just like humans. So I've picked out a couple of specific species or families of animals to talk through specific impact of light pollution on those creatures. Let's start with the bat. This is a large brown bat. It's one of the dozen or so species of bats that are native to us here in Kane County. And a lot of people are afraid of bats. They don't like bats. There's a lot of folklore around bats getting caught in your hair or sucking your blood. But really, bats do a lot of good things for us, not with us. And so there are reasons that we really should care about bats. Bats pollinate fruits and flowers, not here in Kane County, but in other parts of the world. Here and everywhere, bats eat insects. It's their main source of nutrition. And a lot of these insects are ones that destroy our crops, cause different diseases, and think mosquitoes that annoy us. And we're happy to see decreases in those populations as the bats are out there flying around and eating thousands of mosquitoes every evening. The impact that light pollution has on bats specifically, in addition to all those other things that I just mentioned, like circadian rhythms and predation rates, is that bats are, this is an orientation issue. Bats are attracted to the lights on wind turbine towers, and we have more and more of these. Not that this is a bad thing. We need new sources of energy. But with the bats, when they're attracted to those lights, there's a decrease in pressure in the area around those spinning blades. And as the bats approach those towers, the pressure in their lungs changes and they go through barotrauma, which is similar to the bends in a scuba diver, and their lungs actually burst. So they're killed directly often by these wind turbine lights. And then indirectly, bats often suffer too when there are two species of bats that are feeding on insects attracted to artificial lights, like a street light or a porch light. Some species are more agile and able to exploit those insects drawn to the light, like a little brown bat, but these larger ones, like the big brown bat, are more bulky and can't turn on a dime as well. So they're displaced and they're outcompeted by those more agile species. So the bigger ones suffer. Insects. This is a very beautiful white-lined sphinx moth. So there are many reasons that we should care about insects and how light pollution is impacting them. And beauty is one. This is just a very beautiful moth. A lot of people think only butterflies are pretty, but there's some beautiful moths out there as well. Many of them are active nocturnally. Insects are important because they pollinate most of our fruits and flowers. 80% are our flowering plants, and 75% of our food crops depend on insect pollinators. I've read that 1 out of every 3 bites of food that we eat is dependent on insect pollinators. And there have been recent studies, this citation at the bottom, a study published in 2017, that showed that nocturnal pollinators are actually more effective at transferring pollen while they're active and nectaring and pollinating at night than are their diurnal counterparts. So they just play a really important role in our pollination cycle. Insects are also the primary food source of many animals, including most of our birds and a lot of fish. So when they disappear, they impact those other species, and they play a large role in decomposition. We have stacks and stacks of detritus in our woodlands if we didn't have insects munching away. So those are reasons to care about insects, and unfortunately, insects are in decline. A lot of folks have heard of this term, the insect apocalypse. This term was first coined after a German study published by a group of German citizen scientists in 2017. I always like to mention this, citizen scientists, like a lot of you, I bet at Fermilab that are helping Wally collect data, really do play a real role in data collection and data analysis, and their conclusions really feed science. So the Citizen Science Project showed that in a natural area in Germany, over 27 years, there was a 75% decline in total insect biomass during the period of that study, which is huge. This wasn't one particular species, this was all species, all biomass in that particular area. So this study and a couple others that had similar conclusions are what really helped coin that term, the insect apocalypse, that was cited in this New York Times Magazine article in 2018. So since then, we've heard that term insect apocalypse quite a bit. And there's been several studies recently that show that even though the biggest impacts on the decrease in the number of insects is habitat destruction and pesticide use and climate change, recent studies have shown that light pollution is also a big driver of that apocalypse. This study cited in Biological Conservation in 2020 showed that because of these three reasons leading to decline in insects, that light pollution really does impact these declines in insect numbers. So first being that insects are attracted to artificial lights. You see a picture down here of direct light from a street lamp and sky glow to the right. Some insects are attracted to that direct light, like fireflies and moths. Some are increasingly predated as they're attracted. You can see this bat swarming in to get the easy pickings there under the light. Some don't die immediately, but they circle that light, they keep circling, they tire out, and by the morning, they've died. I've seen reports that up to 1/3 of insects that are attracted to lights at night end up dying before morning.
Yeah,
And then last, oh, go ahead.
I'm sorry, there's that recent study about the effect of these bright white LEDs now being installed on roadways in the Amazon. And that supports the data that you just mentioned. There seems to be as much as a 33% decrease in the insect population as a result of light pollution. Sorry.
No, it's great to have the dialogue going. Yeah, and the article that you just shared with me today, Adam, about the mayfly emergences being drawn to lights on bridges near rivers is another example of this type of light pollution effect and its impact on insects.
Right, during their very short life cycle of only about 6 hours, instead of mating and laying eggs, they're circling these lights and dying.
Yeah, in the millions.
Yes.
Yep. And then lastly, we've already mentioned the poster child of night sky impact, light pollution impact, is the firefly, where the mating signal would be obscured, especially in a direct light. But there are other examples too, maybe not as dramatic as the moth and the firefly, which, a lot of people like moths and fireflies. But if you look down in the bottom right of this, this diagram here, D, this is the lowly dung beetle. Even the dung beetle is impacted by light pollution. Dung beetles forage on piles of dung, and they also use celestial cues to migrate, to take their ball of dung food and roll it away from the main pile to an area where there's not going to be as much competition from other beetles so that they can snack in privacy. Well, they use those celestial cues, but if the light pollution obscures the moon or obscures the stars, they often end up circling randomly and end up back at that main pile and face increased competition for devouring that wonderful snack. So just really many impacts on insects, not just the ones that we love to love. Birds, light pollution impacts birds. Unfortunately, this is probably the saddest news that most of us know about collisions with lit buildings. I probably don't have to convince you why it's so important to, why we should really care about birds, because a lot of people enjoy birding. But just a couple of quick facts. Some birds are nocturnal naturally, like this barred owl over here to the
Looks like we might have lost Barb again.
Yeah, I think we should just wait a few minutes and see if she can recover.
Right.
Unless you have anything else to add, Adam, while we're waiting.
Well, we'll just talk about insects a little bit. Moths are the most significant nocturnal pollinators that we have. And of course, certain plants depend exclusively on nocturnal pollinators. Of course, many pollinators benefit from both nocturnal and diurnal pollinators, but this, there she is. Barb, I was just talking a little bit more about the
Good.
insects.
So I'm glad you're filling in. Comcast is the worst. Go ahead.
Well, I was just talking a little bit more about the insects. I don't know if you can bring your presentation back up.
Oh, we lost it. Yep. There we go.
Yeah, but I was just talking about the significance of moths with respect to pollination.
Yeah. Moths and specifically in the evening, probably the hawk moth is probably the one that comes to mind most often in pollination. And birds, we don't have but one pollinator here in the bird area, and that's the hummingbird. So that is active in the daytime though. Birds also disperse seeds, so the fruit eaters will eat the seeds and fly to a remote area and poop them out. Additional seedlings sprout there. And the hummingbird does indeed help pollinate plants, a couple of others as well. And birds are bioindicators. By watching bird populations, we can know something is going wrong in the ecosystem and take action quickly rather than waiting for it to really crash. And lastly, they just bring a lot of joy and economic upside. A lot of active Audubon and ornithological societies around here that a lot of you belong to them. But unfortunately, birds are in trouble. And this is a study that a lot of you have heard. It's fairly recent, showing that we've lost nearly 3 billion birds in North America over the last, since 1970. This is 29% of North America's total bird population. So these are big numbers, unfortunately. This is mainly caused by habitat loss and habitat degradation, and invasive species like cats, but also right in there in the top 5 is collisions with buildings, with lit buildings. So the impact of light pollution on birds includes those that are active at night, but mainly those that migrate in the evening. So our birds that migrate at night do so because it's cooler in the evening in warm climates, and there are also less predators at night than there are during the day. So as they're migrating, they use those magnetic and polarized light and celestial cues. And you can see this skyline in Chicago with that light, just beaming out from these skyscrapers. It really impacts the orientations of these birds. They're drawn to the buildings. They can't use their celestial clues. Even with the sky glow, that's enough to obscure the celestial cues. So it really throws them off course. The impact of this is that they are distracted from their natural activities. If they don't die immediately after colliding with these bright high-rise buildings, there's mortality, just like with insects, from circling and being disoriented. So as they're flying around these buildings, it takes energy, a lot of it, to keep on flying through the night and circling and going nowhere. They have less chances of finding food, more chances of being predated upon, and just like insects, I don't know the percent of birds that end up dying because of wasted energy and tiring out, but it's significant. And how many birds are we talking about here? Well, unfortunately, quite a few. 70% of all birds are migratory. And of those 70%, 80% of them migrate at night. So in total, just over 50% of all birds in North America migrate at night. They typically fly along a series of 4 flyways as they're going from one continent to another and crossing North America, going from south to north in the spring and the other direction in the fall. And one of the flyways is right here, right near us. Cuts right through the Chicago area, the Mississippi Flyway.
what Barb was going to say, will say, when she comes back, is light pollution at night is especially dangerous for migrating birds. When, of course, they're up in the sky flying their path to where they're going, they're typically doing so based on their navigation skills that, of course, they've accumulated through the generations before them, right? But with respect to these bright white LED lights, especially at the top of the buildings, the birds are brought out of their flight path and they start to circle those buildings. Barb, I think I'm just continuing with the story. But you're on mute.
Thank you. Thank you for continuing.
Sure.
All right, so the number one position is not an enviable spot to be. But there are things going on even now that are helping to correct that. So a study by the Field Museum found that by turning the lights off and just in one building, that reduced migratory bird death around that building by 80%. So there is an effort in Chicago especially to decrease the amount of light that's being used in these tall buildings, and it's called Lights Out Chicago, and it's been in place since 1995, and they really had an impact. This is organized by the Chicago Audubon in conjunction with a lot of the building owners downtown, and they encourage, especially the top rows of lights, to be turned off to help the birds, especially during migration, like the spring migration that we're in now. Adam, did you have a comment there about Lights Out Chicago? Is that something?
Well, Lights Out Chicago has been around for quite a long time, and they're composed of tremendous volunteers who at night may be out. Certainly in the morning they're out. They're trying to document, monitor how many birds are striking these buildings. And they're also helping to save these birds. So for some of the birds that just tire and they're resting on the sidewalks, or maybe they strike the buildings but they're not yet dead, these incredible volunteers are picking up those birds, and ultimately a lot of these birds find their way to the Willowbrook Wildlife Center, where they're treated by specialists there. So an incredible group, and these Lights Out programs have now expanded to many other cities, including most recently Philadelphia and Houston.
Great. Okay, I'm going to close discussing the impact of light pollution on plants. This is an area that, when people think about people, think about animals, they know there's something that light does there, but most people don't realize how important scotobiology is to plant life. I'm going to go through this quickly. Plants are the bottom of the food chain. Their life on Earth would end if we didn't have plants. Plants supply us fiber, linen, cotton, hemp. They generate oxygen through photosynthesis and water through transpiration. They improve our air by filtering pollutants and improve water quality by reducing erosion. They are large sequesters of carbon. Trees alone sequester 13% of the US's carbon emissions. And there's been a lot of studies lately that a walk in the woods and not only improves your physical health and makes your body more healthy, but makes your mind more healthy too. Decreases depression and anxiety, and just leads to a better outlook. So plants do a lot of things for us, but they're very light dependent. So most people know that plants photosynthesize, but plants have evolved over time to really be regulated not just by light timing, like seasonal changes of light, but intensity of light and wavelength. Those all tie together to provide cues to the plants to tell them when to flower, how big to grow. So aside from using light as an energy source for photosynthesis, they use light to inform many of their physiological processes, like phenological changes through the season, things like timing of bud burst, flower formation, seed setting, leaf fall. All of this depends on the timing, intensity, and wavelength of light. Form or growth form of the tree, how tall is it, of the plant, how tall does a tree have to get into the light above the canopy, informed by light timing, intensity, and wavelength. And resource allocation, how much energy should be allocated to root growth, for instance, depending on the amount, intensity, and wavelength of light. And it's not just the intensity and the wavelength of light that are important to plants. It is the photoperiodism, or the length of day and the length of night. That's the definition of photoperiodism. That's really what causes species to flower at certain times of the year, causes them to switch into reproductive mode. But scientists have concluded, though, that it's not just the light that's important to plants flowering, it's the amount and the timing of darkness as well. So that's part of this photoperiod too. Photoperiod includes the light and the lengths of light and dark. So plants can be classified basically into three groups depending on their preferred photoperiod. On the left of this panel, we see our short day plants. These tend to be the spring and the fall flowering plants like mums, and they require long periods of night and short periods of day to flower. The second group of plants are the long day plants. These are plants that tend to bloom in the heat of summer, where the days are the longest, like this iris. There's a third group that are day neutral, that don't really depend on photoperiod as much. They use other cues to flower. But let's look a little bit more at this data here. So in a long day, which is the leftmost column of data in both of the right and the left panel, so the one where the day is long, the night is short, you can see that the short day flowering plants will not bloom, but the long day flowering plants will. Now, we have the reverse situation with a short day and a long night, middle bar on both of the panels. The short day flowering plants do bloom, the long day flowering plants do not. But what's really interesting is the farthest right bar on both of these panels that shows the situation when there's a short day, long night, but the night is interrupted by a flash of light. The short day plants are especially impacted by this artificial light in the evening sky, light pollution. And they see this as it's no longer a long night. That flash of light fools them and they don't flower. So the impact of light pollution is really strong on these short day flowering plants, which are a lot of the ones that we have here. And they won't flower. If they don't flower, in that period of uninterrupted darkness, that's what's really important to stopping them from flowering. And without flowering, there's no seed setting and there's no reproduction of the plants. So light and darkness have a real big impact on our flowering plants. But we can easily solve it. That's the good news. It's in some cases as easy as turning off your light, getting large buildings to turn off their light, and other things too that Adam's going to talk about that have to do with light wavelength and light intensity. So with that, I'm going to stop sharing my screen and turn it back over to Adam.
Thanks, Barb. Yeah, you know, the most important thing that we can do, because light, the different types of light affect certain wildlife friends and plants differently. But what's universal is that light affects everything. So the best thing for you to do is just simply turn the light off, okay? I just want to emphasize that. So let me go back to my screen share. Oops, looks like we're back at the beginning. Here we go. So yes, we can make a difference. And fortunately, it doesn't take a lot. Light pollution is one of the forms of pollution that we can all address quite well. So to the extent that you want to be more of an advocate, like me, for example, being a delegate for the International Dark Sky Association, you can approach your municipality and try to encourage your municipality to maybe be more dark sky friendly. You can approach your municipality and ask them to become International Dark Sky certified, like Homer Glen, like Beverly Shores in Indiana, which was one of the first International Dark Sky municipalities. Most recently, Hawthorne Woods. So if you want to be an advocate and approach your local environmental commission or maybe your municipality and try to educate them to be more dark sky friendly, terrific. You can also maybe just try to do what you can with respect to your neighbors. Remember that slide where I talked about light trespass? Well, we want to set the example, right? So we want to let neighbors know that we're doing what we can to be more friendly to our nocturnal environment. But as part of that too, you can send letters to your neighbors. I did a crazy thing last year. I prepared two letters, one that kind of addressed lightning bugs, and then a follow-up letter that kind of addressed moths. And I gave this letter to everybody on my street. Now, fortunately, I live on a pretty short street. And honest to goodness, I'll bet you maybe 50 to 60% of my neighbors actually made a difference. And the kids were really excited about the opportunity to see the lightning bugs, right? Because the neighborhood was just more generally dark. So you can try to do something crazy like that. But otherwise, what can we do with respect to our own residential homes? Well, this is kind of a little roadmap from the International Dark Sky Association. The first thing we want to think about is whether that light that we have on our property is actually useful. Do we really need that light? Sometimes we don't. And of course, for those lights that we do need, we don't need to have them on all night. So the most important thing you can do is reduce the amount of lights that you use at night. And for the lights that you do need, remember to turn them off after a certain period of time during the night, maybe when you go to bed at 9 o'clock, okay? Because again, to the extent that people think that more lights are gonna help you with security, that's just isn't true. Otherwise, for those lights that you feel the need to keep on all night, shielding is so incredibly important. Make sure that light bulb is within a fixture that shields that light down more or less at a 45-degree angle. You really don't want to see the bulb. All right, that's something that you want to try to remember with respect to the fixture that you choose. And with the bulb that of course is within the fixture, you want to try to reduce the brightness level of those lights. You might see that these bright white LEDs are almost like bullets. They shine so obtrusively at us as compared to the sodium lights that we once had. And then if you can, control that light. Again, as I mentioned, turn it off, put it on a timer. With these LED lights, now they're dimmable. So at certain points in time during the night, you can reduce that brightness 20, 30, 40, 50, 60, 70%. And that's especially significant for municipalities and commercial businesses and things of that nature. And then lastly, the color of the bulb itself is very much important. Is it more bright white light? Is it more amber? And what we've found through all the research involving these LEDs that are now being used in such a widespread manner, it's that more amber color light that we want to try to use as compared to those more bright white lights. And that's more or less what we had with the sodiums, okay? It's these bright white LEDs that are exposing us to the light that affects our melatonin and so on and so forth. So a couple examples, just looking at the fixtures. We see the one on the left, it's exposing light everywhere. And of course, as we move to the right, we can see that we've got a fixture that's exposing, that's focusing that light downward. We want lights at times, but we want to be sure that we're shielding that light down and not out and up. Here's another example of shielding. So if you look to the left, we've got fixtures that are not shielding that light bulb. And what do we have? We have light trespass, we have glare. The intent, I'm sure, of those lights was to light the apron, okay, and the garage doors. As we look to the right, that's where the light is focused. And it's focused there simply because we decided to use a different fixture. So we don't have the glare, we don't have the light trespass, and even more importantly, we don't have that sky glow. Simple fix. Here's some examples of some fixtures from a Home Depot near me. So as you look to the left, we've got more dark sky friendly fixtures, right? As we look to the right, we've got more light fixtures that are not dark sky friendly. We see these coach lamps everywhere. You can see the bulb. It's not a dark sky friendly fixture. You can also see to the right that we have some shielded light fixtures. But importantly, what I'd like you to see is that all these fixtures are more or less the same price. So you're not necessarily paying more for a dark sky friendly fixture. And in my humble opinion, I think many of these dark sky friendly fixtures are more attractive. Anyway. The International Dark Sky Association has, for residential homeowners as well as for municipalities, hundreds of dark sky certified, IDA dark sky certified fixtures available for you. So if you go to www.darksky.org, you can go to a page that will actually take you to IDA certified dark sky fixtures that you can purchase actually at the IDA site. So you'll see the choices and you can say, oh, I like that one. And the IDA website will actually take you to the store, more often than not Home Depot, because Home Depot is somewhat working with the IDA, and you can actually purchase that fixture right online, right from the IDA page. And of course, that fixture will be sent to you by Home Depot. So moving away from the fixture into the color of the bulb, right now with LEDs, color is measured by Kelvin. So you're going to see things like 2700K or 3000K or 5000K. The 5000K bulbs mimic daylight. We don't want to use those bulbs outside. That's got that bright white blue light that of course affects our health. But then again, we don't necessarily want to use 3000 Kelvin either. That too has too much bright white light. So in my humble opinion, and the IDA right now is recommending, not more than 2700 Kelvin. So when you go to the store, look for 2700 Kelvin. You'll see somewhere on the package 2700 Kelvin. And I've got an example for you right here. There's some bulbs, 2000's more amber, 3000's more amber, but we want to stay with that 2700 at most. So here's the example I wanted to refer to. These are packages from my Home Depot, okay? Now, with every hardware store, you're going to see different packages. Everybody's got a different package. But what you'll find is for 2700, if you can't find 2700K, on the box, but you will, look for soft white. Please don't use anything more than soft white outdoors. Anything more than that just is not needed. You can see we've got the daylight bulb down at the bottom left. That's at 5000 Kelvin, bright white, blue white LED. May be great for indoors in the basement or maybe in the garage, but for outdoors, you're just mimicking daylight. You're turning day into day night. And then you've got the 3000 Kelvin to the right of that. It's typically labeled bright white. Again, don't use that outdoors. Might be great for indoors if you want to use it for reading purposes, but only the 2700 Kelvin or less outdoors. Oh, and I want to emphasize brightness real quick. I'm sorry. So brightness, typically we measure that from the context of watts. although with LEDs now lumens is used. So you can see on this package, we've got 60 watts. All right, try to use 40 watts. That's the least bright option. If you go up to 100 watts, you're too bright. So outdoors, try not to use anything more than 60 watts, which is basically the equivalent of 800 lumens. 40 watts will basically be the equivalent of 450 lumens. That'll control the brightness level. I sometimes have a hard time finding flood lamps that are soft white, that are 2700 with less lumens, less watts. I was able to find some at the Home Depot recently. It may be hard to find at most hardware stores, but you know, you might have to order them. But otherwise, for the standard light bulb, you should be able to find the 2700 soft white with fewer lumens, fewer watts, pretty much at any store that you visit. So just to wrap up real quick, you can see from the examples here, if we go to the top, that's the bad, right? We've got more lights than we need. Those lights are bright white LEDs, and they're very bright. As we go down, we can see that we've eliminated all the lights that we really don't need. The only light that we really needed probably was the light for the stoop, right? So we can find our way in and out of the house. Our neighbors, our visitors can find their way in and out of the house. We're shielding that light down at a 45-degree angle. It's less white, bright white, blue, and of course it's more dim. It's less bright. And here's a nice picture, again, of a nice IDA evening, International Dark Sky Evening. You've got some nice fixtures. You've got a nice amber color light bulb. And of course, it's less bright and we can all see the stars. And the moths are happy and the wildlife is happy and everybody's happy. And we sleep better. Some of you might be familiar with Doug Talami's book, Nature's Best Hope. Doug does address somewhat in his book the effect of light pollution. He very much addresses light pollution in some of his webinars. And basically, why is he addressing it? Because of the importance of insects and pollination and the food chain. So if we've got fewer moths, right, because of light pollution, of course, we have fewer caterpillars, which means less food for fledgling birds, and then, of course, less birds. And then I now like to end everything with a request that we all plant oak trees. And we want to make sure that, of course, it's dark so that we've got all those moths and caterpillars hanging out in these wonderful keystone plants to of course, supply our food chain. Remember that most of the food that we eat, we have only because of pollination. So there we go, www.darksky.org. I think we ran a little bit late, but thanks again for joining us. And I'm going to stop share.
Thanks very much, Adam and Bob.
Welcome.
No problem.